Good day, everybody. How are you all? Today, we are going to talk about solving an ANOVA problem using Excel. So I will share my computer screen with you. A researcher wants to determine if there is any difference in the mean. It should be mean weight gains of athletes following one of the three special diets. Athletes are randomly assigned to three groups and placed on diet for 5 weeks. The weight gains are shown below. At alpha equal to 0.05, is there any difference in weight gains? So let me make those small changes here. So it is weight gains, and here in it will be the mean weight, in the mean weight. Okay, so we are going to use ANOVA to compare the means. So our null hypothesis is H sub 0 mu A, which is the mean of population A, is equal to mean of population B is equal to mean of population C. So that's your null hypothesis. Your alternate hypothesis is at least one of the mu's is different. So in order to conduct this test, we will be comparing variances. Basically, we'll compare the variations in each group from the grand mean. So mean of each group, how far it is located away from the grand mean. Grand mean means the mean of all the samples that I have over here. Group diet A, diet B, and diet C included. What is the grand average? So we will look at the variations of each diet mean from the grand mean. Okay. And we will also look at the variances inside each population or each sample, diet A, diet B, and diet C, the data that we have. So the idea is if the means of if the mean of A equal to mean of B equal to mean of C, that is if the null hypothesis is true, then the variances, two variances are equal. That is variation of each treatment mean or if group mean from the grand mean is close to the variation within each group of data. Okay, so therefore we are comparing two variances. Okay, and when we compare two variances, we take ratio of variances, and that statistic is called F statistics, which is a positively skewed curve. That is, it has an extended tail on the right side. It starts from 0. There is no negative F value. So without further ado, let me go to data on my computer screen. I have already activated the data analysis tool pack in Excel. So I will go to data analysis tool pack and then select ANOVA. ANOVA single factor. What does it mean in this case? That means we are just comparing one factor, which is three different types of diets, A, B, and C. Okay, so we will highlight ANOVA single factor and select OK. Then in the first line, it asks for the input range. So the input range is all of this. We will highlight all of this. Okay, so we basically highlighted from diet A beginning to diet C end. Okay. Also notice in the first row inside the highlighted cells, we have labels. So we'll click here, labels in the first row to make sure the Excel knows that we have labels in the first row. Our alpha level of significance is 0.05. Okay. So we are ready to do the test. Group by data, group by columns, sorry, because you have diet A in the first column, diet B in the second column, diet C in the second column. So again, we are comparing two variances. One, the variance of the mean or the variation of the mean of each diet A, diet B, and diet C from the grand mean, that is the mean of all the samples. Secondly, we are calculating and comparing the variances within each of the sample of data, diet A, diet B, and diet C. If these two variances, that is the variation of the sample, each sample mean from the grand mean and the variation within each sample, if these two variances are about the same, then the means are equal, okay? Then the null hypothesis is true. If the two means are not equal, then the F ratio will also not be close to 1. So let's, because F ratio is the ratio of two variances. One, the first one, which is the variation of each sample mean from the grand mean, and the second one is variation in each sample. If these two variances are close enough, then F ratio will be close to 1. But let's take a look. So I have highlighted everything that I need to know, and then new worksheet apply means the answer will come out in the new worksheet, and I hit OK. Okay. Non-numeric data. Let me see what do I have. 10, 11, 8, and 6. C12. Non-numeric data. Where is non-numeric data? This, the rest. Okay. So make sure labels in the first row is clicked and then hit OK. Okay. Now it is calculating. So let's okay. Let's take a look at this table. Okay. So the first summary is the summary statistic of each sample, diet A, count, average, variance, diet B, count, sum, average, and variance, and diet C, count, sum, average, and variance. Now, ANOVA, sources of variation. This is called ANOVA because it is analysis of variance. So when we are comparing more than two means, we use ANOVA, which is analysis of variance. So we compare two variances. One, variation of each sample mean from the grand mean, and the second variance is variation within each sample. If these two variations are about the same, then F ratio will come to 1, and then we can come to the conclusion that the means are equal. Okay, let's see what we get. So between groups means between each diet group. Okay, look at the mean square. Mean square is nothing but the sum square divided by degrees of freedom. Sum square is the first variation that I told you. It is the variation of each sample mean from the grand mean squared, and that is divided by degrees of freedom 2. Why? Because there are three treatments or three groups, A, B, and C. So 3 minus 1 degrees of freedom is 2. So sum square divided by degrees of freedom gives you the mean square of the variation of each sample mean from the grand mean. And now we look at within groups. Within groups, as I told you, variation within each sample. That sum square is 69.58 divided by degrees of freedom of 11. So you are wondering where this 11 degrees of freedom came from. It came from the total number of counts. The sample size is 14. 4 plus 6 is 10 plus 4 is 14 minus the 3 that you have 3 columns, diet A, diet B, and diet C. Okay, so 14 minus 3 gives you the degrees of freedom within groups as 11. And sum square divided by degrees of freedom gives you the mean square within groups, variation within groups. Now for F statistic, we take the ratio of the mean square. MS means mean square. SS means sum square. Mean square between groups divided by mean square within groups. And that ratio F statistics in this case is 7.598. As I told you, this is a right tail test. Okay. So F value is always positive, and we always look at the area on the right of the test statistic under the F curve. And that P value is 0.008459. So P value is less than alpha. Okay. P value is less than alpha. Remember, alpha is 0.05. So our decision, so we write down P value is less than alpha. Maybe we can write it in the other spreadsheet that we have. Sorry, this one. P value is less than alpha. So what is P value? P value is the probability of getting a test statistic as extreme as what we obtained from this data, as extreme as what we obtained. Okay, and p-value is less than alpha because p-value, I remember, was 0.00 something, right? So p-value is less than alpha. P-value is the probability of getting a test statistic. So we can go back. Test statistic is 7.598. P-value is 0.008. P is less than alpha. Decision is reject 80. Is reject 80. Okay. So conclusion is at alpha equal to 0.05, there is enough evidence to support HA, which states at least one of the mu's is different. Mu's is different. So just for a minute, if we look at the sample data, look at the mean. The mean of diet A is 5, mean of diet C is 4.75. These are close, but the mean of diet B is, well, much higher. It's 10.16, much higher than 5 and 4. So at least one of the means is different, and I'm thinking the mean of diet B is significantly different from the mean of diet A and diet C. Therefore, we reject the null hypothesis. Also, the F statistic is not close to 1, and the p-value is less than alpha. Therefore, we rejected the null hypothesis. So I will stop here today. If you have any question or comment, you can write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. I really appreciate that. If you like this video, please share this video with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner of the screen. I will see you next time with another interesting problem, interesting solution. Thanks for watching. Take care. Have a nice day. See you next time.